All right, so as we go into the next unit, we really need to make a distinction between deductive and inductive arguments. Um, Lavin does this a little earlier in his book, but I think it's actually good to wait a bit because you really don't need this to make sense of the argument diagramming stuff. It's not honestly super helpful there. But as you get into more formal logic, it is very important. So, philosophers, logicians, scientists, mathematicians, people who study argument generally divide arguments into two types, deductive and inductive. Now, there are some people who will argue there are more types of arguments. A common one people say that exists beyond deductive and inductive is abductive arguments. I don't know if this is true or not. For our purposes, it doesn't matter because you really don't need to know about those to evaluate most common kinds of argument. That's even if you think that that's another way to slice up, you know, to divide up what arguments exist, put them into boxes. They're not going to pop up in anything you really do in normal life or in this class. So the general consensus is these are the two kinds of arguments. More importantly, these are really the only kinds of arguments you need to think of in day-to-day life to evaluate arguments. It is important to think about this distinction because how you evaluate an argument, really will depend on is it inductive or deductive. And so the difference between the two is how the premises support the conclusion. What kind of support the premises provide for the conclusion. In a good deductive argument, and I know that phrase is really vague, which, usually in logic, vague is very bad, right? We will define more exactly what it means, but for the time being, I think it's helpful just to talk about good deductive arguments. Anyway, in a good deductive argument, if the premises are true, the conclusion must be true as well. We'll talk more about this in a minute, but in a deductive argument, if the form of the argument is good, it is impossible to even imagine a way that the premises could be true and the conclusion false. Inductive argument, on the other hand. In a good inductive argument, if the premises are true, it makes the conclusion more likely to be true. In a good inductive argument, the premises are true, the conclusion's more likely to be true, but there's still some chance it is false. Deductive, there isn't. So some examples of deductive arguments. Someone can only legally become a citizen of the U.S. if they're a natural-born citizen. Sorry, not citizen. Someone can only become president of the U.S. if they're a natural-born citizen. Arnold Schwarzenegger is not a natural-born citizen. Natural-born means either your parents were Americans or you were born in America. Schwarzenegger, his parents were Austrians. He was born in Austria. He's a naturalized citizen, but he's not a natural-born citizen. So Schwarzenegger cannot legally become president. If these premises are true, and they are, it is impossible for Schwarzenegger to legally become president of the U.S., right? Second one, it is immoral to do anything that puts the lives of innocent people at a high risk of harm. No matter how careful we are in fighting a war, it will always put the lives of innocent people at severe risk. Therefore, it is wrong to fight a war. These premises might or might not be true. We might disagree. You might say, well, maybe sometimes it is acceptable to do things that put innocent people at risk. But if the premises are true, the conclusion has to be true as well. Here's a really simple one from math. I don't know, this is so simple I don't think any mathematician would ever use it, but whatever. I'm not great at math, so we'll use a simple one. There is no largest number. You can always add 1 to any number. That means that for any supposed largest number, you can always add 1 and get a larger number, so there is no largest number. If these premises are true, conclusion has to be true as well. Now, let's look at some inductive arguments. And you notice the difference here. Laura is young and healthy people are unlikely to get severely ill if they get COVID. What's more, she has been vaccinated, and that makes it even less likely she will get severely ill if she gets COVID. So Laura is unlikely to get severely ill if she gets COVID, right? Look, if these premises are true, and Laura doesn't exist, I just made her up, right? But let's assume she does. She is young and healthy, and she has had a shot. Both of those make her really unlikely to get severely ill if she gets COVID, but it's still possible, right? If you're a 22-year-old marathon runner, you are very, very unlikely to die of COVID, but there are young, very healthy 22-year-olds who have in fact died of COVID. In the same way, if you have a shot, you're really unlikely to get severely ill, but some people who've had shots get severely ill, right? Young, healthy people who have had shots, even less likely to get severely ill, but it does happen, right? It's super rare, but out of millions and millions of people, it's going to happen a few times. It's really unlikely, but Laura might be one of those really unlucky people. Chances of winning the lottery are 1 in several million. So if you spend money on lottery tickets, you'll likely lose it all. Index funds are these things you can buy that sort of mirror the stock market, usually return an average of 8% interest every year. Therefore, you are almost certain to have more money for retirement if you invest your retirement money in index funds than if you spend it on lottery tickets, right? This conclusion is almost certainly true, right? If you spend all your retirement money on lottery tickets, you're likely to lose all of it. You're really unlikely to make any money. If you put your retirement money in index funds, you're probably going to get 8% interest a year. That's what the stock market grows on average for a very long time, But look, this is not certain, right? Some people win the lottery. You plow your money into lottery tickets, you might win. Very, very unlikely, right? 1 in several million. Even if you buy a bunch of tickets, it's probably 1 in several hundred thousands. But it might happen. And by the same token, index funds usually return 8%, but you might retire right after there's a massive depression. The stock market might fall by like 20 or 30% or something. You might lose a bunch of money. It's really unlikely. Even if the stock market falls right before you retire, the interest from the other years will probably balance it out, but it's not a sure thing, right? There is some chance that the conclusion is false, even if these premises are true. Here is an even longer one. Turns out that a decent percentage of star systems have planets, and some of those planets seem to be a lot like Earth. This is true. Since there are hundreds of billions of stars in our galaxy alone, there are almost certainly tens of thousands, if not more, Earth-like planets in our galaxy alone. Again, this seems to be true. And there are billions of galaxies, if not more, so there are trillions of Earth-like planets in the universe. Even if life forming is really unlikely, given that many planets, it will almost certainly form on some, and some of that life will likely become intelligent. Therefore, humans are almost certainly not the only intelligent life in the universe. Billions, maybe trillions of planets in the universe that seem a lot like Earth, Given that many, even if life is really unlikely to form, it's going to form on a bunch of them. If life forms on a bunch of planets, chances are some of it will become intelligent, right? But for everything this argument says, it might not be true that there's, more intelligent life out there. It might turn out that even though it's really likely that life will form elsewhere, it just didn't, right? We might be alone in the universe. It's not likely if this argument's true, but it is possible. Now, Lavin gives you a bunch of words that are kind of key, good, clues whether an argument's deductive or inductive. I'm not going to go through those. He does a perfectly good job in the book. But, I think you should, one thing, you should just learn to recognize deductive or inductive arguments. Hopefully we'll get good at that in this class. But you might also, and this isn't infallible because both kinds of arguments pop up a lot of different places, but, they're more common some places in some fields than others. Deductive arguments are the bread and butter of most mathematics. Just about any argument you see in mathematics, there's some exceptions. They might be about something being probable or not, but for the most part, arguments you see in mathematics are going to be deductive arguments. Deductive arguments are also really common in moral reasoning, which you'll see in philosophy. They're also common in legal reasoning. Most arguments you're going to see in the law are going to be deductive arguments, right? Inductive arguments are very common in medicine, right? We've studied hundreds of thousands of people who took the drug. Most got better, so you'll probably get better if you take it, right? Common in many other sciences, right? We have studied, hundreds of thousands of animals, and this chemical doesn't seem to harm them, so it's probably safe to release in the environment, right? Also, any field that deals with probability, gambling, investing, insurance, so on and so forth, right? If you get deeply into inductive logic, you'll see that a lot of the arguments talk about gambling. That's because, well, it's pretty common there, but also, people like gambling because it's a good way to illustrate inductive principles. Anyway, hopefully you guys just see that there are, these argument types pop up more commonly in these places, so that's one way to pick them out.